So today I would be covering some Newton's law of gravitation problems that is related to NEET and AIIMS paper. So the first question says mass m is divided into two parts, xm, that means my m1 is xm and my m2 is 1 minus xm. So for a given separation, the value of x for which the gravitational cause attraction between the two pieces becomes maximum. So here we need to find when the gravitational attraction between two pieces becomes maximum. So force is given as gm1 m2 r square. Now you need to put these values into this equation. So it will be gm square r square x 1 minus x. Now as you know, we need to find maximum value. So in this case, we need to find del f over del x equals 0. That means we need to derivate the value of f. So it will be like this: gm square r square x 1 minus x. As you can see, these all are constant, so these will be neglected. So it will be del over del x minus x square equals 0. Now I would derivate this, so x will be 1 and x square will be 2x, so it will be 0. So 2x equal 1, so it will be x equal half. That means when x is equal to half, then the gravitational attraction between two pieces will be maximum. Let's start with the next one. So the next one says three identical point masses, each of 1 kg, lie in the xy plane at points 0, 0, 0, 0.2 m and 0.2 m, 0. The net gravitational force on the mass at the origin is. So let us suppose that we have A at origin 0, 0, B at y-axis, that is 0, 0.2 m, and my C will be on x-axis, that is 0.2 m, 0. So this is how the figure will. Now we need to find the net gravitational force on the mass at the origin. So first of all, I would be finding FAC, the force between A and C. So it will be GMA MB R square AB. And it is in the x direction, therefore I would be writing I cap here. So we have identical point masses, each of mass kg, 1 kg. So that means MA, MB and NC is 1 kg. So G value is 6.67 into 10 raised to power minus 11. MA is 1, MB is 1, cross I cap. R square AB will be 0.2 because the distance between A and C is 0.2. So the answer for this one is 1.67 into 10 raised to power minus 9 I cap Newton. Now similarly you need to find for FAB. So similarly FAB will have same values and it is same, that is 1.67 10 raised to power minus 9, but it will be in J cap because we have in y direction. So it will be opposite, that is J cap here. That's the difference. So net force will be, you have to add these two. This is my first and this is your second. So you have to add these two. You will get your answer as 1.67 into 10 raised to power minus 9 I cap plus J cap. So it is the first one, but there is some mistake here. Let's move on to the next one. The third question says acceleration due to gravity on moon is 1/6 of the acceleration due to gravity on Earth. If the ratio of densities of Earth rho m and rho e is rho e rho m 5 by 3, and then the radius of Moon Rm in terms of Re. So let's find this. So first of all, you should know what is acceleration due to gravity in terms of density. So it is G equal 4 by 3 pi rho g r. Now as you can see that G is directly proportional to rho r. So you can write it as G proportional to rho r, or you can write it as Gm equal rho m Rm, and Ge can be written as rho e Re. Now I will equate these two. So my Rm over Re will be Gm over Ge, and we have rho m, but it will be rho e here, and this will be rho m, because if I find Rm value from here, so it will be Rm equal Gm over rho m. That's why. So as you know that rho e over rho m is given as 5 by 3. So I will equate the value of 5 by 3 here, and Ge, Ge in this case is given as 1 by 6. So it will be 1 by 6 into 5 by 3. So it will be 5 over 18 Re, because Re is here. So my equation is Rm equal 5 over 18 Re. That means the first value. So let's start with the next one. If the radius of Earth were to shrink by 1%, its mass remaining the same, the acceleration due to gravity on the Earth's surface would decrease by 2%, remain unchanged, increase by 2%, increase by 1%. So as you know that G is inversely proportional to 1 by r square. So as r decreases, G increases. If r decreases, G will increase. So we need to find the percent change in G. So percent change in G is 2% change in R. So as it is given that percent change in R is 1%. So 1% is equal to 2%. So acceleration due to gravity increases by 2%. Let's move on to the next one. Radii of two planets that are respectively R1 and R2, and their densities are respectively ρ1 and ρ2. The ratio of the acceleration due to gravity at their surfaces is. So we need to find acceleration due to gravity at their surfaces. So first of all, acceleration due to gravity is 4 by 3 pi rho gr. So as you know, we need to find g1 over g2. So g1 over g2 will be 4 by 3 pi rho 1, g is same, r1, and for g2 it will be 4 by 3 pi rho 2, g r2. So I can cancel this out, cancel out g as well. So it will be rho 1 r1, rho 2 r2. So the right option for this is the D part. Let's move on to the next one. The acceleration of body due to the attraction of the Earth at a distance 2r from the surface of the Earth is g, acceleration due to gravity at the surface of the Earth. So we need to find g dash over g. So the formula for g dash over g is G dash over G is given by R and R plus H because depends on height and square of it. Now it says that H is nothing but 2R. So you need to replace H with 2R. So R over 3R, that means R can be cancelled out. So 1 by 3 whole square will be 1 by 9. So it will be G dash equal G over 9. A part. So thank you for watching.